In this question, we've been presented with a solution of hydroiodic acid, and what we've been asked to do is calculate the concentration. We've been given the volume, the mass of the acid in the solution, and we've been provided the formula HI, and we've been asked to give our answer to effectively three decimal places. Now, in this particular case, one of the things we would need to look at is, well, what are some of the relevant equations for resolving this? We would need to look at, as we know, in terms of concentration, we've got moles equals concentration times the volume, right? So that would be moles, so that would just be mole, is equal to the concentration and that would be in moles per dm cubed multiplied by the volume. Which is in dm cubed. Another equation which in this case would be relevant, and I will explain the relevance, but would be that the mass in this case would say, well, the mass in grams is equal to the moles. Well, the moles, I mean, let's do that, just moles. The moles multiplied by the molar mass. And in the case of molar mass, that's going to be in grams per mole, right? Now, as I mentioned, in this case, we've been presented with the volume, and we've got a mass, and we've got the formula. So, one of the things I'm going to do at this stage is look at, well, what is the actual molar mass? How do we work that out? Because we've been given the formula, we can use the periodic table to work this out. Okay, so, and why I'm doing this is because the moles will be relevant when we get to, as you can see, when it gets to working out the concentration. So if we take a look at the periodic table excerpts, which I've got here, we can see we've got, okay, 126.9 and hydrogen. So we can see this is just HI, right? HI. So that's literally just 1 plus 126.9. Right, so I'm just adding these two values, right? And that's going to give us 127.9, right? So the molar mass, so I'll just write that as the molar mass here is going to be 127.9, and so that is going to be very useful as we progress in this question. Okay, so at this stage we have this value, we have this value, so we have the mass, we have the molar mass. We do not yet have the moles. I mean, we could quite straightforwardly work that out. I'm not going to do that at this stage, but what I'm going to do is a substitution. So if we just, I'm just going to rearrange this so that we've got the moles on one side of the equation. So with this equation, I'm going to divide both sides by the molar mass, and if I do that, we get mass divided by molar mass. and then divide that by the molar mass, we obviously would get like 1 effectively. So we get moles. So moles is mass divided by the molar mass, right? What I'm going to do at this stage is I'm going to substitute this into the equation we have here above. Okay, so what we're going to get when we substitute this is that mass in grams divided by the molar mass is equal to the concentration times the volume, right? Right, so now we've got that in a format where, well, still we haven't actually made the concentration the subject of the equation. So how we're going to do that is we're going to divide both sides now by the volume, right? And if we do that, you can kind of see based on visual inspection, but what we get is concentration is equal to the I am actually going to keep the units in here because it's quite important in this case, and we'll get to that, but I'm going to keep the units in this rather than just skipping that. Concentration equals, and then if we do as I mentioned, what we're going to get would be mass in grams divided by molar mass multiplied by volume. Well, no, yes, well, you get the point. It's what I'm effectively doing is I'm multiplying this side of the equation by 1 over volume, right? So 1 over volume. Like that is what's taking place. So obviously on the bottom we know we would have multiplied by the volume. Just for clarity. Right. Okay, so here's the issue, right? So we've got this quite straightforward equation how we can now work out the concentration from the numbers we already have. However, the volume has been presented to us in centimeters cubed. This equation, as you can see, this is in decimeters cubed, right? So what we need to do is have some sort of conversion factor in place so that this relates to actually a centimeters cubed situation. Now, what you may understand at this point is that when we convert volume from decimeters cubed to centimeters cubed, essentially what we need to do is multiply the given value as we have it in decimeters cubed by 1000. Okay. So in order for us to do it in this case, we could because we're starting, actually what we're starting with is not a value in decimeters cubed but in centimeters cubed. When we're doing the substitution, I'm going to just use a space up here, the volume in decimeters cubed is effectively equal to the volume in centimeters cubed divided by 1000. Okay, And this is in terms of the unit conversion, just converting the units to the decimeters cubed value. The reverse, therefore, if we now substitute that in to this equation we have, you notice that because the volume is actually on the bottom, this would effectively be like adding volume, like it's effectively like 1 over, right, times 1 over volume over 1,000. This being, in this case, is the mass, right? So in order to straightforwardly simplify it, how we would integrate into this equation is simply the concentration is equal to the mass in grams multiplied by 1,000, right, then divided by the same, basically, but then this would be in a cm cubed. So molar mass if we use this equation which we've just come up with now, this would effectively get us in a positive direction with respect to getting the answer. So if we just plug in the values you've got here, in addition using also the 127.9, so I'm just going to quickly do that, right? So what we've got 24.429 multiplied by 1,000, and then the molar mass and the volume. So as I mentioned, the molar mass in this case is 127.9, right? So we need to take that as well. So then multiply that by the volume, right? And in this case, the volume, as we know from the question, is 422 centimeters cubed. So I would invite you to work that out on your calculator, what the concentration comes to so far, right? And if you do work that out, what you should find is that it would be equal to 0.45260. Now, okay, so we've got this long number which corresponds to the so far what we've got from calculating the concentration according to the equation. But in our question, we have been asked, give your answer to 3 decimal places when necessary. So we would need to do some work on this to actually get to what we could reasonably say, okay, this is our answer, right? So effectively that would then be equal to 0.453, right? So, and what's missing at this stage is just the units, right? So we would need to add our units before we can reasonably say, okay, yes, we've got the answer. So that's 0.453, then moles per dm cubed, right? Okay, so there you go.